Sun. A hot, glowing sphere of gas that we call the Sun, brings the heat and light necessary for life on Earth and creates seasons and climates. However unique the Sun may be, it is just an ordinary star, one of the 200 billion stars in the Milky Way galaxy. The Sun is located in the Milky Way galaxy, where the average distance between stars is about 8 light-years. Like more than 90% of the stars, the Sun is in a stable phase of its life. In the hot, dense core of the Sun, hydrogen is converted to helium due to nuclear fusion reactions. In this process, energy is released and gradually finds its way to the surface. From there, it escapes to space mainly in infrared and light radiation. The rate of energy production on the Sun and its surface temperature have remained almost the same for 4.6 billion years and will remain the same for a long time. That is until the hydrogen in the central furnace runs out. At this time, the Sun turns into a red giant. Its energy output is increased by burning helium, destroying the inner planets. The Sun turns white as a dwarf after losing its outer layers. The Sun's diameter is 1.39 million kilometers, and its mass is 330,000 times Earth's. The Sun comprises 73.5% hydrogen, 24.9% helium, and 1.6% other elements. The star's energy output is 385 million billion gigawatts, its surface temperature is 5,505 degrees Celsius, and its core temperature is 15.7 million degrees Celsius. The surface layer of the Sun, known as the photosphere, emits visible light that we can see from Earth. This layer is 500 kilometers thick, and its density is about 600 times less than the air we breathe. Its average temperature is 5,505 degrees Celsius. Density, pressure, and temperature increase gradually as they penetrate deeper into the Sun. Below the photosphere is a convective zone. Gas streams that bring heat from the interior to the surface of the star flow in this area and are transferred. Hot gas bubbles with a diameter of 1,000 kilometers ascend to the star's surface, cool for 8 minutes, and go back to the lower layers, making it look like the Sun's photosphere is boiling. The next layer is the radiative region, a quiet region in which energy reaches the convective layer slowly from the nucleus. The nucleus, which is the Sun's nuclear reactor, accounts for only 2% of the Sun's volume but 60% of the star's mass. The Sun's thin atmosphere comprises an area called the chromosphere and crown. Photosphere illumination usually does not allow us to see these areas directly. The chromosphere starts above the photosphere and continues up to 2,000 kilometers to reach the crown. The temperature of this region gradually increases and reaches 10,000 degrees Celsius in the upper regions. The Sun's outer atmosphere is called the corona, which is 1 million times less dense than the photosphere and extends millions of kilometers in space. This area is thought to be heated by magnetic processes, and the corona temperature rises to 1 million degrees Celsius. Matter in the Sun is scattered in space at a rate of several million tons per second. The Sun may seem like a bright, clear, calm star, but if you look closely, it is a chaotic world. Its surface seems to be boiling. Tongues of fire erupt from around magnetically active regions known as sunspots, and massive explosions scatter their material into space. Now let's talk about sunspots. The amount of heat radiation from the Sun is reasonably constant over time, but its surface or photosphere changes. The dark areas, known as sunspots, appear independently or in groups on the star's surface and last for several hours to 2 months. These spots are typically between 1,500 and 50,000 kilometers in diameter, and their number varies over 11 years. They were once thought to be the solar system's inner planets passing in front of the Sun. Still, in 1612 the Italian scientist Galileo correctly identified them as the Sun's surface roughness. Richard Carrington, an English astronomer, discovered in 1863 that spots move faster in the tropics than near poles. This difference was because different areas of the Sun rotate around the axis of rotation of the star at different speeds. Sunspots occur because this difference in velocity affects the Sun's magnetic field. A sunspot is 2,800 degrees Celsius cooler and 1,000 kilometers deeper than its surroundings. Spots are areas where a strong magnetic field prevents hot gases from reaching the Sun's surface. Their dark center, known as the shadow, is surrounded by a ring of lighter areas called the penumbra. The magnetic field lines are located below the Sun's surface and between its poles. In the tropics, the Sun rotates faster than in the polar regions, causing the magnetic field lines to become closer in part. Eventually, this process causes them to accumulate and flourish on the surface, creating stains. When the disrupted lines of the magnetic field in the area of the sunspots repair themselves, they suddenly release large amounts of energy. This release of energy produces glowing flares of light, radio radiation, and X-rays. The activity of sunspots occurs at specific intervals. Spots first appear at latitudes of 40 degrees north and south of the Sun. Between 1645 and 1715, few spots were recorded, and this period of low activity of sunspots coincided with a series of very cold winters on Earth, known as the Little Ice Age. This led to the hypothesis that the activity of sunspots affects the Earth's climate. Although the amount of solar energy output varies slightly during each cycle, the amount of X-ray and ultraviolet radiation differs considerably. These energetic radiations react with the upper layer of the Earth's atmosphere in the ionosphere. These spots may also affect the amount of ozone layer in the Earth's atmosphere and the formation of clouds. In 2008, solar activity was minimal, and only a few spots were visible. However, in 2001, the number of spots was very high. The last time the number of spots peaked was in the spring of 2014, and the new solar cycle, which began in 2018 or 2019, is expected to continue for several more years. Today, most research on the Sun is done by spacecraft that constantly monitor solar activity. They can capture images of the Sun at different wavelengths and examine the chromosphere and the corona.